in this video, I'm going to start looking at the topic of motion, and these are the things that I'm going to look at and hopefully you'll be able to do once I finish the video. So we're going to define some key things. We're going to define distance, and we're going to define the gradient of a graph. Then we're going to get on to describing what different gradients look like and how we can link that into average speed, which is really what this video is about, calculating average speed and describing average speed from graphs. So let's get started with defining distance. So the distance traveled is essentially how far an object moves, and we typically measure it in meters. Sometimes we might measure it in centimeters or kilometers, but the standard unit of distance is in meters. So you can see we've got this car that's moved. We're going to measure the front of the car when it starts, the front of the car at the end, and the distance between them is what we're talking about when we say distance traveled there. So we measure to the same point on the car. Okay, so that's distance. Now let's now define what I mean by a gradient of a graph. So I've just drawn a random straight line graph on here. So what I'm going to do is I'm going to pick 2 points on this graph. So I've just called them x1, y1 and x2, y2. You can call them whatever you like. And what I'm going to do is I'm going to find the change in y and I'm going to find the change in x. And the reason I'm doing that is because the gradient of a graph is the change in y divided by the change in x. So in this one, the change in y is going to be y2 minus y1, and the change in x is going to be x2 minus x1 there. So that's what I mean by the gradient of the graph, and that's how we calculate the gradient of the graph. So what we're going to have a look at now is how we would describe different types of gradients. So the first example we're going to look at is where we've got two straight line graphs here. So what we would say is that the gradient of the red line is more steep than the gradient of the green line, the other graph there, because we can see it's angled up more. So that's how we would compare two gradients like that. So one of the things we say about gradients is how steep they are. The other thing we can describe is whether they are positive or they are negative. So on both graphs, I've put in a horizontal dashed line, which is a line with zero gradient. So on the left, we can see the line goes upwards from that line. So we describe that gradient as positive. On the right, we can see the line goes downwards from the gradient equals zero line. So we describe that gradient as being negative. Okay, so that's whether a gradient is positive or negative. So just like before, so what if we have two negative graphs? How do we compare their gradients then? Well, what I'd say is the red line, the gradient is more negative because we can see it's a steeper line, so its gradient value would be more negative. So that's how I would compare those two graphs there. Okay, so that's how we would compare gradients in terms of how steep they are and whether they're positive and negative. Let's now get into average speed so we can start linking all this together. So first thing, average speed is the distance traveled by an object divided by the time it takes to travel that distance. So another way of putting that is that the average speed is the gradient of a distance versus time graph. Because we can see for the gradient, the change in y would be the distance it's traveled, and the change in x would be the time it's taken. So we can see the gradient will be equal to the average speed for that section there. So how we define average speed, let's actually look at some example calculations for it. I've got a graph here which has essentially two straight line sections, and we can see that after 1 second the speed of the object changes because the gradient of the graph changes at that point. So in the first section, we can calculate the average speed because we can see the change in y is 3 meters, or the distance traveled is 3 meters. The change in x, or the time taken, is 1 second. So 3 divided by 1 gives us an average speed of 3.0 meters per second in that time period there. In the second time period, we can see that the average speed will be 0.5, which is the change in y, divided by 2.0, which is the change in x, giving us an average speed of 0.25 meters per second in that section, which we can see is a smaller value there. So that's how we can actually calculate the average speed. Let's now look at the average speed over the whole graph. So over the whole graph, we can see that the change in y over the whole graph is 3.5, or 3 plus 0.5. You can see that the change in x over the whole graph is 1 plus 2, which gives us 3. So the average speed will be 3.5 divided by 3, which gives us 1.2 meters per second when we round it. So what we would say is over the whole 3 seconds, it has an average speed of 1.2 meters per second there, even though the speed clearly changes in the middle. So that's how we calculate average speed. And let's now use the gradients to compare the average speed. So I've put the values back in that we've calculated. So you can see that in the first section, it has a higher average speed than in the second section of the graph. And we can tell that from the gradient, because we can see in the first section, the gradient is more steep than the second section. So what that means is the speed is higher in the first section than compared to the second section of the graph. So that's how we can use the gradient to describe what's happening to average speed. We can look at how steep the line is there. So that completes the things that I wanted to go through on this video. So take a look through this list and test yourself now. See if you can do each of these things. So can you define distance? Can you define gradient? And can you define average speed? And if you can't, go back to those sections and look over them again. And then look at actually some examples of calculating average speed and looking at different graphs and describing the speed on them, and to make sure you can do each of these skills. So that completes this video looking at average speed. I hope you found that useful. If you have any questions you'd like to ask, please feel free to comment on this and ask me, and I'll try and get back to you as quickly as I can. But thank you very much for taking the time to watch this video.